Okay, so in today's discussion, we will talk about regression analysis. Okay, so now we are uh, doing the inferential statistics, right? Up to skewness and kurtosis, we were doing descriptive statistics, but when we were doing correlation coefficients and these regression analysis, these are parts of inferential statistics. Okay, so we have done correlation, right? Carl Pearson correlation coefficient, then Spearman's rank coefficient for qualitative data or for ranks. Now the next analysis that we are doing is the regression analysis. So let us do some brief about some introduction about the regression analysis. So father of regression analysis is Carl F. Gauss. He lived from 1777 to 1855, and his contributions are to physics, mathematics, and astronomy. Okay, so the term regression was first used in 1877 by Francis Galton. Okay, so what does the regression mean actually? Regression means to fall back to previous characteristics or previous traits. Okay, or previous trends. Regression means to fall back. So it is the study of relationship between variables, like that of correlation. Correlation was also the study of relationship between the variables. So there similarly, regression is also a study between the relationship between the variables. It is one of the most commonly used tools for business analysis, uh, medical statistics, and other types of statistics, even statistics for geoinformatics that you will do this regression analysis. And in many other fields, wherever statistics is used, regression analysis is one of the most important methods. It is easy to use and applies to many situations. Okay, so what is the importance of regression analysis? Regression analysis helps in three important ways. It provides estimate of values of dependent variable from values of independent variable. It can be extended to two or more variables, which is which is known as multiple regression. Then it shows the nature of a relationship between two or more variables, right? So we can do prediction, some kind of prediction, or we can make a we can make an estimate, or we can make a calculated guess based upon the regression analysis, right? So we have to first find out the trend. If we have data, suppose if we have data about previous 30 years about rainfall. Okay, we have data of 30 year of previous 30 years of the rainfall. Then we will see what is the trend, what is the trend in that data. So based on that trend, okay, so depending upon that trend, we can do what? We can make a guess what sort of characteristics the rainfall is, the data of rainfall will be having in future. How much rainfall uh, can we expect in the future? Okay, so that is based on the regression analysis. Okay, so there are different types of regression. One is single explanatory variable. That regression is known as simple regression, which uses only single explanatory variable. Okay, so there will be one dependent variable and one independent variable. Okay, so one independent variable will be the explanatory variable that is causing uh, the change in the dependent variable, not causing that can be explained by the independent variable. Okay, so if there is change is happening in the y-axis depending upon the x-axis, then we can, if there is a relation correlation, then we can explain the change, or we can predict the change in the y variable uh, based upon the change in x variable if there is a correlation. Okay, then other type of regression is multiple regression. It includes any number of explanatory variables, so there may be more than one your independent variable that are also known as explanatory variables. Okay, so this is how the equation is going to be. Why this is the dependent variable, so its equation is going to be b naught plus not b but beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. This is for uh, and in this equation these betas are the coefficients, and x1 x2s are the explanatory variables or independent variables. When we have only two variable, like that can be represented simply on two-dimensional graph, on independent variable on x-axis and dependent variable on y-axis, then simply the relationship or uh, this equation can be turned into the equation of a straight line or any curve. Okay, so what are the dependent variables? The single variable being explained, predicted by the regression model. Those are known as the uh, depend dependent variable. Suppose one example that I gave you in the what you say correlation, that uh, you have the height of 30% and you have the weight of the 30%. So height of the 30% is being represented or is being yeah represented on is being represented on x-axis, and weight is being represented on y-axis. So in that case your x or height will be your independent variable and weight will be your dependent variable. Your change in weight depending upon change in height, uh, that the graph will be showing, the graph uh, whichever, if it is a linear graph or any curvilinear graph, that will be representing the relationship between your height and weight, right? When you draw two-dimensional graph, so that graph will be representing the relationship between your height and weight. So suppose what would happen, mostly what happens when in this type of case, in this specific case where you have height and weight, because as the height of a person increases, weight also increases mostly. So it will give you a straight line that as the weight increases, as the height increases, weight also increases, right? So it will give you a straight line. So in this case, change in weight or increase in weight can be explained by change in height. That because there is a change in height of a person, that is why change in weight of that particular person is happening. So change in weight can be explained by the independent variable. Independent variable is height, that due to the height, because height is increasing, that is why weight is increasing. Because when height is increasing, you have more mass, more bones, etc., other things in your body, those mass is also increasing, so that is why weight of a person is increasing. So so dependent variable is the single variable being explained or predicted by the regression model. Okay, then comes your independent variables, the explanatory variables used to predict the dependent variable. So in our case, independent variable is height and dependent variable is weight. Okay, so explanatory variable used to predict the dependent variable. Okay, then comes the coefficient. So the values computed by regression tool reflecting explanatory to dependent variable relationship. Okay, so we are going to take, or simply we will start with relationship between two variables. okay, or regression model for two variables. So what that beta, what this coefficient is going to be, because I have already told you that in two variables you are simply going to get two dimensional graph. One variable will be on the x-axis and one variable will be on the y-axis, right? So suppose if you got linear relationship between the two variables, that as you are increasing the height, the weight is also increasing. So what kind of line you will get, what kind of graph you will get? You will get a straight line. So beta would be what? Because you will get straight line, so beta would be the slope. Beta would be the slope of that line, right? Then comes the residual. So the portion of the dependent variable that isn't explained by the model. Okay, the model and under and over predictions. Okay, so there will be two types of residual: under and over prediction. Okay, so the model will explain some amount of that. This amount of weight can be explained by the change in height. Okay, but if the change is more than that, that will be error. Okay, that will be residual. So now regression analysis, let us, so there will be linear regression and there will be non-linear regression. These are the types of regression. Okay, so in linear regressions you will have straight line relationship of the form. So this equation that was the general equation for the regression model, this will become like this when you have two variables x and y. And if the relationship between them is linear relationship, then this equation for the regression model or regression model will become like this equation for the straight line. Okay, so this equation will become this for two dimensional, for two variable having a linear relationship. And for non-linear relationship implies curved relationship like logarithmic relationships and other relationship. You must have seen the graph of x square, x cube, right? So they are the graph for x square and x cube, they are not straight line graph, they are some curve graph like that of your eclipse. Okay, the parabola, those are not straight line graph, those are some curved graph. So if you get relationship that follows the non-linear path or non-linear trajectory, then those types of regression analysis will be termed as non-linear uh, regression analysis. Okay, then cross-sectional regression analysis, data gathered from the same time period. Okay, when you have data from the same time period, then that type of analysis will be known as cross-sectional. But when uh, your data involves when your data is observed over equally spaced point in time, then that will be known as time series. Okay, so what is simple linear regression model? Only one independent variable. Okay, only one independent variable will be there, that will be represented on x-axis, your independent variable. Relationship between x and y is described by a linear function. Okay, so the regression analysis or regression model will form a straight line, and regression model will have a linear equation. Okay, the regression model will have a linear equation. So relationship between x and y is described by a linear function. Changes in y are assumed to be caused by the changes in x. Okay, so why, in our example, why there is a change in weight? Because there is a change in height, because the height of a person is increasing, therefore the weight of the same person is increasing. So the change in height, sorry, change in weight is due to the change in height. Okay, so there are different methods for studying the regression. One is graphical method, another one is algebraical method. Graphical method is freehand curve or least square. Then algebraical method is least square, deviation method from arithmetic mean, deviation method from assumed mean. We will do least square as well as the other method also. Okay, this deviation from arithmetic mean, we will do this also. So we have already done this types of regression model. So these are similar to that of your correlation, that when all of your data points are falling along a straight line and are close to that line, this line in regression model is also known as line of best fit. Okay, so when all the points are falling or are falling very close to this line of best fit, then there is a positive strong relationship, right? But here it is also have a strong relationship, but the nature of relationship is negative because the slope is negative. What it means that as your x variable is increasing, your y variable is decreasing. And here if you draw a line of best fit, okay, you can see that all the points are scattered, they are not falling on this line. But how do we draw this line of best fit? That we will see. That is that you will find out by using that linear equation. Okay, so let us see estimated regression model. The sample regression line provides an estimate of the population regression line. So this will be your equation. This is the equation of what? If you remember, this is the equation of a linear straight line, right? This is the equation of a straight line. Y equal to y cap equal to b naught plus b1 x. In this equation, variable y is your variable on the y-axis. B naught is what? Your intercept. B naught is your intercept, and b1 is the slope. B1 is the slope, and x is the independent variable. That is how your lines are. Equations of a straight line is. If you do not remember, look at this. This is the equation of a straight line. The equation of a straight line is usually written this way, right? M equal to mx plus b. This is the equation of a straight line. Y is what? Your variable on the y-axis. That is represented here by y. And m is what? M is the slope. What is the slope? Slope is this. Change in y divided by change in x. So dy by dx. Dy by dx, this is the slope. So x is the variable on the x-axis or the independent variable. Okay, and b is the intercept. What is intercept? In this case, in this diagram, you see at intercept is the point at which your straight line is cutting the y-axis. So this straight line is cutting your y-axis at 1, right? This straight line is cutting your y-axis on 1, so your intercept is this 1. So this is your intercept from 0 to 1. Getting a point? This is the equation of a straight line, and this will be the equation of the line of best fit. Okay, so how do we, so what line would be the line of best fit? What I am trying to say is, let me change the sharing mode. Okay, let there's a straight line. Okay, so these are the graphs. Here you have x-axis and y-axis, suppose. So this is your dependent variable and y is your independent, x is your independent variable and y is your dependent variable. So we are having bivariate regression model here. Okay, we will be doing bivariate, means only two variable x and y. So suppose we have data points. X is, suppose x is representing what? X is representing height. This x is representing height, height, and this y is representing what? Weight, wt, weight. Okay, so suppose we have 30 students. So data for 30 students is what? That one student have height 4 feet or whatever. He has weight this. Let me dot with red. Okay, so he has this. Another student have height like the plot for other student is this, 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 this. So you have plot like this. So what what is line of best fit? So you have to, okay, so you have to draw a line. You have to draw a line that is representing the trend. That what is the trend in this plot? This is a kind of scatter plot, right? Points are scattered in your graph and you have to represent the trend. That what is the trend? So here you can see that as the graph is approximately representing, in this graph you can see that as your height is increasing, your weight is also increasing. So you can see that, yeah, it can be represented by a straight line, by a straight line. So suppose that straight line is this. Okay, but we, it is clear that this relationship or the model will be a straight line model. Okay, but the thing is, how will you draw the straight line? Where this straight line is going to be? What will be its slope? Because this straight line could also be like this. This straight line could also be like this, right? This straight line could also be like this. So which straight line is going to be your line of best fit? So what is the line of best fit? Line of best fit is that line that is fitting, as the name suggests, that is fitting the best all of your data points, or what I mean to say, that is representing most of the data points as nearly as possible. So what I mean to say is, suppose I am drawing another graph. Suppose if you have points like this. Wait a second. So suppose if you have distribution of points like this, right? If you have distribution of point like this, then I ask you to represent the trend of the data, represent the trend in the data set. Okay, how will you represent the trend? How, in which model can you fit all these points? It is simply just by saying it, it is following a straight line. So if you draw a straight line, suppose if you draw a straight line, if you draw a straight line, you can see that this model or this line that we are drawing is fitting all of the points very well. All the points are falling on the this line, right? So this line is representing all of the point. Getting my point? This straight line is representing all of the point. But suppose if there were points like this scattered all over the place, then you have to decide. Here you can simply here you can simply, just by looking, by no calculation, you can draw the straight line. The line would be uh, that line would be the line that is crossing all the points, because it can, because all the points are falling on falling on in a straight path. So you can represent all the points uh, with zero residual. There is no gap between the point and the line. But in this case, but in this case, you cannot simply draw a line just by looking at it. Why? So what, out of all these lines, which line would be your line of best fit? So what is the line of best fit? Line of best fit is a line which is representing all of the points as closely as possible. Okay, so what would that be? So here you can see in this model, this is the perfect line. Okay, this is the perfect model, all the points are falling. You can see that the difference between the distance between the points and your straight line, that is the model, okay, is zero, because all the points are falling on this line. Okay, so distance between the points and the lines are zero. But in this case we cannot make it zero. We cannot make the distance between, the summation of the distance between the points and the line zero, but we can check for what, that the distance should be minimum. Getting my point? Let us let us make another one. So suppose I have 3 points. I have 3 points. Suppose one line could be like this. One line, oh, sorry, one line, oh, I cannot draw straight from the mouse with the help of mouse. So suppose one line is like this. So here the distance between this point and this line is very small. Similarly, the distance between this point and this line is very small, but distance between this point and this line is this big. So you have to add up all the distances. Add up all the distances. Okay. So suppose this is point P1, this is point P2, and this is point P3. So the distance here is, suppose, D1 plus D2 plus D3. This is the distance. Another line could be a line that is going from where? That is going from 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 at this place. Okay, that have this slope. In this case, the distance is D2 plus D3. Okay, so what would be the line of best fit? What would be the line of best fit in your opinion? The line of best fit would be the line in which, if we take the distance between these points and the line, the sum of those distance will be minimum. That is what we can do, right? Here was also the distance was minimum, but because it was the perfect model, all the data points were lying on the same line, so the minimum in this case was zero. But here we do not have all the points lying on the same line, so we have to check the line that will have the distance between the line and the points minimum. That would be our line of best fit. So how do we find out that distance? So for that we have different methods. Okay, so one method is equation of line having the least mean square. So one method to find out the equation of that line is uh, is to find out least mean square from the model line. So this line is known as the model line. Okay, so we have to minimize, as I said before. It can be shown that one straight line that minimizes s square, minimum of square of error or residual. The least square estimate is given by b is equal to sigma x minus x bar multiplied by y minus y bar divided by x minus x bar square. Okay, so you can see this formula is almost similar to what, if you remember, the formula for uh, the formula for correlation was what, or the for what was the formula for your correlation, or for covariance? What was the formula for your covariance? Formula for your covariance was, covariance formula was sigma x minus x bar y minus y bar n. This was the formula for what? This was the formula for covariance. This is very similar to that. Okay, so here this, what is this b here? This b is the slope. This b is the slope, not slope, but here b is your intercept, but here b would be your slope. This b will be equal to your slope in this line. Okay, this is the equation for this is the equation for the line, for a straight line. So here we have got uh, a equal to y bar minus b x bar. Okay, so here b is the slope. So what we are doing here, basically we are finding out the equation for the line that is fitting the best all the data points. We are basically finding out the equation for that line. We know what is the basic equation of the line, but we have to find out that particular line. So how do one line will be different from the other? Because all the lines will have basic or the same general equation, but how one line would be different from the other? How one line would be different from the other? X and y are, these could be anything because these are variable, but how could be the equation of one line would be different from the other? Because all the different line would have different slope and different intercept, right? Because different lines would have different slope and different intercept. You can see this line, this black line is having different slope, so therefore its intercept would also be different. What would be what would be its intercept? Its intercept would be, oh, sorry, its intercept would be this. This is the intercept for the black line. And what is the slope? What is the slope for black line? Slope for black line is this, right? And what is the intercept for this green line? The intercept for this green line is this. This is the intercept for green line, and the slope of green line is this. So how one line is different from the other line? What are the characteristics that distinguish one line from the other line? We have two characteristics. One is the intercept, another one is the slope, right? So for the line of best fit, because there could be any number of lines, I have told you, you can draw any number of lines, but what line will be the line that will best fit the data? So for that we are finding out the m is the slope, and b is the intercept. Our equation was, if you remember, y equal to mx plus b. So how one line be different? How one line would be different from the other? By its slope and by intercept. So for the line of best fit, we are finding out the slope and its intercept. Okay, so that is what we are doing. So here in this equation, we are representing slope with b and intercept with a. Okay, and y and x are mean of the data. Y is the mean of the data, x is the mean of the data. So slope of the line of best fit can be found out by this sigma x minus x bar y minus y bar divided by sigma x minus x bar square. So this will give you the slope of the line of best fit. Okay, and how are we getting this? this is this is we are getting with the help of least mean square. That I'm not showing here how do we get to this point, but there is a derivation up to this point. There is a derivation up to this point. We are taking the distance of a point from the line and squaring it, and then we are uh, doing the derivation. Okay, we are doing the derivation and then we are finding out the minima and the maxima, right? So for the minima, it should be for that distance to be minima, it should be 0. So then we are putting it to be 0, and that is giving us this equation. Okay, so but we are not going in that in the derivation. You simply remember that this equation for slope is available to us by the derivation through least mean error, least mean square error. Okay, so the regression equation. So you will understand. Let us let us understand with an example. So last 5 year, 5 randomly selected students took a math aptitude test before they begin their statistics course. The statistics department has 3 questions. Okay, what linear regression equation best predicts the statistics performance based on the math aptitude scores? If a student made an 80 on the aptitude test, what grade would we expect her to make in statistics? Okay, so here in the second point, we are being asked to make a prediction, to make a guess that if a student made an 80 on the aptitude test, what grade would we expect her to make in statistics? So how the question is expecting us to make prediction about the marks of a student in statistics based upon the marks of the students in aptitude test, because there must be some correlation. So we have to first find out that is there some relationship, okay, that we can generalize in the model. Okay, then how well does the regression equation fit the data? Okay, so let us see in the table below. The x1 column, or sorry, xi column shows on the aptitude test. Similarly, yi column shows the statistics grade. Okay, so student, there are 5 students. X1 is their number in aptitude test, and in y column their number in statistics grade. In x aptitude test score, in y statistics score. Okay, so firstly, uh, uh, we have to find out x minus x bar, y minus y bar. Okay, here is again x minus x bar square, here y minus y bar square. You cannot see here bar, but it is bar, y minus y bar square. Then it is x minus x bar and y minus y bar. So you will draw the table. We get sigma of x. This is the mean. 78 is the mean. So this is x bar. This is the x bar, and from this column we are getting the y bar. Okay, so we can find out, or we can calculate all these values for these different column. So x minus x bar multiply by y minus y bar. Y bar x bars are what these means, 78 and 77. This is your x bar, this is your y bar. Okay, so we can find out this column also, x minus x bar, y minus y bar. Okay, So if I want to, if I try to draw this question or this data on, on the graph, this is how its scatter plot is going to be. Okay, one student having mm, 60 marks in the in the aptitude test is having 70 marks in what, in your statistics test. Another student having 70 marks in aptitude test having 65 marks in what, in statistics test. So by plotting we are getting this scatter plot. Now we have to, so to make a prediction, first uh, we have to find out the we have to generalize the trend. We have to find out what is the trend, what is the line of best fit. Okay, so we have to fit the data in a model. By fitting the data in a model means we have to find the equation of the line that is best representing the data. Okay, so what, so I have represented that this is the line of best fit, but how do we get to this line of best fit? This line must have some specific intercept, right? What would be its specific intercept? If I, what would be its intercept? Hmm, okay, so the regression equation is a linear equation of the form. We know that because here we have two variable. Okay, here we have two variable, and from the graph itself, from the scatter plot itself, we can see that we can generalize the data or the trend in the data with a straight line. Okay, so the equation of the straight line is y bar y bar equal to b naught plus, here it is cap, but treat it as a bar. Okay, y bar it is equal to b naught plus b1 x bar. So to conduct a regression analysis, we need to solve for b naught and b1. So as I have already told you that we have to find out the slope of the line. B1 is the slope and b naught is the intercept, right? So to find out the equation of the this regression line or the line of best fit, we have to find out these two coefficients. One coefficient is your slope, another coefficient is your intercept. Okay, so how do we find out? Computations are shown below. Notice that all of our inputs for the regression analysis come from the above three tables. Okay, these tables, all of our data are coming from this table. So how do we find out the slope? I have just shown you, this is the formula for the slope, right? This is the formula for the slope: sigma x minus x bar y minus y bar divided by sigma x minus x bar square. So this is the equation for the slope of the line of best fit, or for the slope of the regression line. This is the formula for the slope. So we will employ this formula and substitute the values in this and find out the slope of the line of the regression or the line of best fit. Okay, so this is the formula: sigma x minus x bar multiplied by y minus y bar divided by sigma x minus x bar square. So this value of for this term we know from this table: x minus x bar multiplied by y minus y bar. Summation of this column is 470, right? And summation for x minus x bar square, this column is 730, 730 here. So we will just put these value, and we are getting the value of b1, that is the slope, 0.644. So this is our slope of the line of best fit, right? So we now know b1, the slope. In place of x and y, here we will substitute it with x bar and y bar. And what are x bar and y bar? These are the mean values. So we will put these mean value of mean value, that is y bar here, x bar here. We get the value of b1 here. The only value remaining is p naught. So we can find out that. So once we know the value of the regression coefficient b1, that is the slope of the line, we can solve for the regression uh, intercept. Here it should be intercept. Here it should not be slope, it should be intercept. Okay, regression intercept. So we know y bar is how much. are we are getting this value from this table. So value for y bar is 77, value for x bar is 78. Okay, how do we get this equation? This is simply the rearrangement of this equation. Okay, this is the equation for straight line. So this is the simply the rearrangement of this equation. So in place of y bar we are putting 78, in place of x bar we are putting 77, and in place of b1 we are putting 0.644. So this is how our equation is becoming, and by solving this we are getting b naught, that is the regression intercept of the regression line, that is 26.268. Therefore the regression equation is y equal to 26.768 plus 0.644x. So this is the equation of the line of best fit or the regression line. So now because you now have the equation for your regression line, you can make prediction. As I have just said that for to make a prediction you have to first find out the model, or to find out the equation. Okay, find out the equation of the line of the regression. So now simply they are asking us, the question is asking us that if a student is getting 80 marks in the aptitude test, means if x is 80, in other words if x is 80, what would be the value of her marks, sorry, not value of her marks, but what would be the marks of her in the statistics exam, right? So simply they are asking us that if the value of x is 80, what would be the value of y at that point, at x equal to 80, what would be the value of y? So we will just simply put the value of x 80 here, and we will get the value of y. Getting this? So these two portion is all that we are going to do today. Other things we are going to discuss in the next session.